Hello, welcome to 2.1 for domain and range. I debated doing this along with piecewise functions, but I figured it'd be good to get it out of the way and also review some function notation with you. So, reviewing function notation or introducing it for the first time, depending on who you had as a teacher in Algebra 1, 2. This right here is not f times x, this is f of x. That means that this is a function of x. So what that means, it's really the same thing as y equals 2x plus 1. It's just a different way of writing it. And one of the ways that that can be helpful is with something like this, f of 3, instead of having to write evaluate to find y when x equals 3. F of 3 is quite a bit more efficient. So in this case, when there is no x sitting there, we know what x is. And we don't have to solve anything, we just have to evaluate. So something like that would look like f of 3 equals 2 times 3 instead of x plus 1. So 6 plus 1 equals 7. So f of 3 would equal 7. Now, when I have f of x, that means that I don't know what x is. And so what I'm looking at is solving for y. Not y, just kidding. Solving for x when y equals 11. So what that would look like is 11 equals 2x plus 1. Subtract 1 from both sides. It's got 10 equals 2x. Divide by 2. So x equals 5. So in one case, you've got no x's when you're all done. In the other, you have to find what x is. You have to solve. So it's the difference between the solving and evaluate, depending on what those are in. Now, that's not super important to what we're talking about today, but I do still want to introduce it and make sure we're all comfortable with it. The next thing is what makes a function, and its defining factor is that, or its defining part is that it can only have one output for any given input. And I'll explain that in a second. So there's only one output, y value, for any given input. That's the x value. The other way to look at this when we're looking at it as a graph is that it passes the vertical line test. And so what the vertical line test says is that if I draw a vertical line anywhere on my coordinate plane, it's only going to pass through the graph one time. So this first one, if I draw vertical lines all over this thing, that orange part of the graph is only going to be crossed one time by any of those vertical lines. So if I'm looking at this as, say, an x value of -1, there's only a single y value for that. If I look at this as an x value of -5, there's only a single y value for that. And so this one passes that vertical line test. The next one, same thing, and you don't have to draw a ton of them, but this one starts to look like it goes straight up, but it still has a little curve to it. So this one also passes that vertical line test. The next one, this one doesn't matter. We can do a lot of lines here. For x equals 3, for example, we have a value of about 1.5 and about -1.5. So we have two different y values. And that is not a function, and it doesn't pass our vertical line test. Same thing with the circle. If I draw those vertical lines are crossing through that circle twice. So that is not a function. Next one, same thing. If I cross this, I've got 2 points there. that it crosses, not a function. Next up, only one. Linear ones, those are pretty much always a function. I don't know when I would say always a function instead of pretty much, but they're always a function. So that one's good to go. This one, that slight dip there, doesn't matter, also a function. Okay, so domain and range, real briefly. Domain is the set of all possible x values. Those are those vertical lines. Easiest way to think about this is if you go from left to right, what's your lowest point? What's your highest point? And if you have any gaps. Our lowest point here, when we're looking at those vertical lines, is at x equals -1. Our highest point, if we just carry that over, is at x equals 3. So we have a domain here of -1, which is not included, is less than x, which is less than or equal to 3. You can write that in interval form as well, -1 to 3 with the closed bracket. Our range, let's do that one in green. That's the set of all possible y values. And I go lowest. I always want to go lowest to highest there. So if you can just flatten your pencil, like lay your pencil down. Your lowest y value is at -3. And your highest y value is at 5. So the range here is going to go from included because of this closed circle. -3 is less than or equal to x, which is less than 5. Also in interval form, -3, 5 parentheses. So this one, thing you have to be careful about is making sure that you're not mixing your x's and y's. That's why I really recommend those lines. They help people a lot. Open circle versus closed circle, watch out there. We also end up having arrows at some point. So on this one, if I look at this from left to right, and I'm just looking at domain, first thing I encounter on the left side is an arrow that goes out to -infinity. So that tells me, like if I'm thinking about it in terms of interval form, and sometimes it's easier to write it in interval form first, my lowest is -infinity, and as I track it along, my highest x value is 4, and 4 is not included because of that open circle. So you can do that in dashed lines if you want. If I write that in interval form, that is x is less than 4. Not interval, I'm sorry, inequality. For my range, I am going from lowest, which again, this points down and to the left. So that means my lowest, again, is -infinity. -infinity. And then my highest stops at y equals 3. So -infinity to 3. Other way to think about that in inequality form is x is less than 3. When we do piecewise functions and step functions on the next section, these are all going to be in inequality notation, which isn't really a thing, but it's inequality form. So it's important to know how to read those and do both of them. On stuff like this, sometimes when you're going left to right, it's just a little easier to put it in interval form and then think about what that means. Some people have an easier time. Okay, so let's do a couple of. As I concluded the video, I just realized how many times I put x's for the ranges. Those should all be y's. So I apologize if that confused anybody. Examples and that bring in a little bit of weirdness. This first, I'll go one at a time. Scooch this over. So this first one, if I'm looking left to right, my furthest left, I encounter an arrow. So that's not really a boundary. And furthest right, again, we have another arrow that's going out. So if I'm looking at my domain, I have negative infinity to positive infinity. You can also write that as x is all real numbers. So that little sign that looks like an R with another line, all real numbers, means there's no restriction on x. My range, on the other hand, if I start at the bottom, I don't have anything happening down here. This doesn't start until 1. And then as I go up, those arrows are again taking me out to infinity. So what that tells me for my range is that it's everything from 1 up. So bracket, because it does actually touch there. So 1 to infinity, or y is greater than or equal to 1. Coming over here, just want to get this finished. This brings these dashed lines here. These are what are called asymptotes. And asymptotes are lines that a graph will approach but never touch. And we'll talk a little later about why that happens mathematically, but just know that for today. And what we see on both of these, on the domain and the range, is that it's everything going up to that line, because we've got an arrow at negative infinity on each of these directions. We just can't have an x of 2, and we can't have a y of 3. So if we're looking at domain, that's going to go negative infinity up to 2, parentheses, and has to jump at 2, and then 2 out to infinity. So x cannot be 2, so it could be x equals all real numbers except 2. There's a few different ways to write this. And range just can't be negative 3. So negative infinity to negative 3, and then it's going to jump and go negative 3 to infinity. That just tells us it can't be 3. So y, all real numbers, except negative 3. So that concludes that. Just kind of trying to give us a basic idea of domain and range and how to deal with those. And that's it. Have a lovely day.